Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 4-2 for October-November 2023, and this is part 2 for questions 5 to 7. Question 5, a particle A of mass 0.5 kilograms is projected vertically upwards from horizontal ground with speed 25 meters per second. But find the speed of A when it reaches a height of 20 meters above the ground. In my simple sketch here, I can have this particle here projected upwards. It will reach a maximum and maybe come down. The projection here is symmetrical. So maybe 20 is here, 20 meters. And then it is projected with a speed of 25 meters per second going up. Now, here I'm going to use the equations of motion. So using v squared is equal to u squared plus 2as. Okay. The final speed is the one that I'm looking for. The initial is 25. So square then plus 2. Since this particle is moving upwards, that means the acceleration is negative 10. And then the distance traveled is, of course, this 20. So meaning v is going to be equal to the square root of this will be 625, then minus this will be 400, and this will give us 225. Square root of 225 is 15, so we shall get 15 meters per second. Then they are saying that when A reaches a height of 20 meters, it collides with a particle B of mass 0.3 meters. Of mass 0.3 kilograms, which is moving downwards in the same vertical line as A with speed 32.5. So we are having something like this. This one is moving up here, then it collides with another one here. So when the two collide, this distance here, remember this one is moving down, this one is moving up. So particle A, this is particle A down here, and then this is B. So the distance here is 20 meters. Okay, that is that. And then they are saying that show that the velocity in the collision between the two particles, B is brought to instantaneous rest. So it comes to rest, but be sure that the velocity of A immediately after collision is 4.5. Now here we have to use the principle of conservation of momentum. Okay. Now, where we say momentum before collision is equal to momentum after collision. Momentum before collision is equal to momentum after collision. Momentum after collision. Okay, then that means we are going to have MA UA, then plus MB UB, because you know that momentum is product of mass and velocity. So MA VA, then plus MB VB. Okay, so this one, the mass is 0.5, then times the speed it was projected with. Okay, so this is not the one that we are considering here. The speed we are going now to consider is when it is about to hit B, because as it is moving up, the speed keeps on reducing. Okay, at the vertical height, the speed is going to be 0. Okay, at the vertical height. Now, in here we are going to have now our speed, which is given as 15. Okay, so the initial speed I'm going to use here is 15. Not this one it was projected with, not the 25. My point there, it has to be 15, then plus the mass of B is of course 0.3. Now times the velocity In momentum here, you have to be careful with the directions taken. So if A is moving upwards, and I've taken its speed as a positive, then this one, which is moving in the opposite direction, its speed has to be a negative. So we shall put negative 32.5 by the time they collide. Okay, B is moving with that speed there. And then they said that B is brought to instantaneous rest. That means its momentum is 0. Okay, the mass of A here is 0.5 times the final velocity here for which is the one that we are looking for. Then the momentum of B, of course, is 0 because it was brought to rest. Okay, then that means our VA is going to be equal to the 0.5 times the 15. Then we also have 0.3 times negative 32.5. Then we shall divide by 0.5. So what will be our answer here? So we have 0.5 times 15, which is 7.5, then plus 0.3 times negative 32.5. Then down, we shall divide by 0.5. That is negative 4.5. So negative 4.5 meters per second. Now they say that show that the velocity of A immediately after collision is 4.5 meters per second downwards. Now A was moving upwards, okay, with a speed of 15. So it was positive going up. Now, since we have gotten its velocity after collision as negative, that means it is now moving in the opposite direction, which is downwards, okay? So the negative sign, let me write something here. The negative sign, okay, indicates or implies that A is moving in the opposite direction. Is moving in the opposite direction. In other words, downwards. As simple as that. Then part C, find the time interval between A and B reaching the ground. You should assume that A does not bounce when it reaches the ground. They are saying A does not bounce because if it goes and then bounces, then B, which is coming, can again collide with it. So they put that condition there for that reason. Now, this simply implies that A reaches the ground before B, because even its speed after collision is 4.5 meters, and yet the other one, B, is brought to instantaneous rest. You see that? So let me consider these two particles of mine here. I have A here, which is now going to move downwards with a speed of 4.5 meters per second. And then B is here, which is starting from rest. So they are all going down. And they will move through a distance of 20 meters, okay? Through a distance of 20 meters here. Like we have seen before, let me check here. Yes, 20 meters, a height of 20 meters. So that's why you're seeing me putting the 20 meters there. Now let's look at B. I'm going to substitute in S, which is equal to UT plus a half AT squared. So for B, the S of B is going to be equal to, since actually I don't need to put S of B because it is covering 20 meters and it is starting from rest, then plus a half times the acceleration here is going to be positive 10 since it is moving downwards. And then what is the time taken? So this one is going to be 20, then over 5, which we get from here. Then after we take the square root. So this t is going to be 20 divided by 5, that is 4. Then divide by, the square root, that will give us 2 seconds. So that means B hits the ground after 2 seconds. Then how about A? Let's look at A. For A, it is also going to travel 20 meters, okay? Its initial speed is 4.5. Then the time taken, we don't know. And then plus a half. Also here, the A is 10. And then t squared. So this one is giving us a quadratic equation, 5t squared plus 4.5 t, then minus the 20, which is equal to 0. Okay, then I can multiply all through by 10 such that I deal with the positive. Okay, so when we multiply all through by actually by 2, don't need to put in, so by 2 I will get 10 t squared, then plus this will be 90, and then minus 40, which is equal to 0. And then from here I can solve this quadratic. So mod, and then we go to 5, then 3, which is quadratic. So this one is 10 equals then 9, then negative 40. I get 8 over 5, so skip some space. So negative 5 over 2, and then 8 over 5. So 8 over 5, and also t is equal to negative 5 over 2. We first leave some space. I've told you this is how to cheat the examiner. And then you have to show how you solve this quadratic equation. That's why I've left this space here. So cross multiply, you get now the 5t. When I cross multiply here, then now bring the 8 here. Then I'll get my minus 8 here. The same thing here, cross multiply, you will get 2t. And then when you bring this one here, you get a plus 5, which is equal to 0. If you don't put this one and then you just put your answers here, you might lose a mark because they say that attempt to solve the quadratic equation. Okay, so now here I'm going to take the time as 8 over 5 because of course time cannot be a negative. Okay, now the difference in here, the difference, we just get these two and we subtract them two, then minus this 1.6 here. So we get our answer as 0.4 seconds. Question 6. A rail engine of mass 120,000 kilograms is towing a coach of mass 60,000 kilograms up a straight track inclined at an angle of alpha to the horizontal, where sin alpha is equal to 0.02. There is a light rigid coupling parallel to the track connecting the engine and the coach. The driving force produced by the engine is 125,000 newtons, and there are constant resistances to motion of 22,000 of the engine and then 13,000 newtons on the coach. Find the acceleration of the engine and find the tension in the coupling. Okay, this one I'm going to do a small sketch here. Maybe this is the coach here, and then this is the engine here. Okay, this is the engine, and then this is the coach. So there is tension in this rigid coupling. So that tension takes the coach up, but it is the same tension that is pulling the engine backwards. Then the resistance on the engine is 22,000 newtons. The resistance on the coach is 13,000 newtons. Okay, and then there is also horizontal component of the weight of the engine, which is mg sine. Okay, so we shall have 1, 2, 0, 0, 0, 0, then g, then sine alpha. There will also be that mg sine alpha on the coach. So the mass of the coach is 60,000. So then sine of alpha. Okay, then from there we can have, of course, this is alpha here, the angle of inclination, And then there is a driving force, which is given as 125,000 newtons. So using F is equal to MA, we are supposed to look at the forces which are on the engine. Okay, so on the engine, we can see 125,000, the driving force, minus the tension here, this resistance here, and then this mg sine alpha. So minus 22000 minus the tension minus the mg 120,000, but g is 10, so I'll add on that 0, and then sine of alpha is 0.02, which is equal to the mass of the engine. It's given as 120,000, then times the acceleration. Now, when we look at the forces that are acting on the coach, we are having the tension here, then minus these two resistance forces. So tension minus 13,000, then minus 60,000 as the mass of the coach. Then G, let me just add there 10, and then sine of alpha is 0.02, which is equivalent to the mass here is 60,000, then A. Now I will solve these two equations simultaneously. I will just add, because when I add, I will be eliminating the tension here. It will just disappear. And then I will have 125 minus this one here, minus this one here, minus this one here. So all of that together, what do we get if we put in the calculator? 125,000 minus 22,000 minus 13,000, then minus 1, 2, and 5 zeros, 1, 2, 3, 4, 5. Okay, then into 0.02, then there is also minus 6, and then 5 zeros, 1, 2, 3, 4, 5, then times 0.02. So we get 54,000 on the left here, 54,000. And then on the right, 120,000 plus 60,000, that one gives us 180,000 of A. So meaning the acceleration is going to be equal to 54,000, then divide by 180,000. So simplified, divide by 180,000. That is 3 over 10, which is 0.3 meters per second squared as our acceleration. Then to get the tension, I can substitute in any of these two equations. I'm going to use the second one. So the tension is going to be 60,000 times A, which is 0.3. Then this and this can go this other side and they will become positives. Okay, so we shall have plus 13000, then plus 6 and the 5 zeros times 0.02. So putting this in the calculator, what will be our tension? So we have 60,000, then times the 0.3, then plus 13000 plus 6, and then the 5 zeros, then times 0.02. So altogether, this one gives us 43,000. So tension is 43,000 newtons. Just like that. At an instant, when the engine is traveling at 30 meters per second, it comes to a section of the track inclined upwards at an angle of beta to the horizontal. The power produced by the engine is now 4.5 million watts. As a result, the engine maintains a constant speed. And of course, you know that for a constant speed, then acceleration is equal to 0. And they are saying that assuming that the resistance forces remain unchanged, find the value of beta. Now, we know that power is equal to the driving force times the velocity. Okay, So meaning the driving force here is going to be equal to the power, which power is 4.5 million watts. Then we divide by the speed, which is 30. Okay. When we simplify this one, of course, this one can go, and then the 3 can go here, 15. Then we shall add on the 4 zeros. So this will be 150,000 newtons. Okay. So for constant speed, like I've said, acceleration is equal to 0. And remember, we are going to use F is equal to ma. So when you look at the one of the engine, okay, just like before, so the driving force, if we can check here, okay, we are going to consider the driving force, then the T, okay, the tension, we are going to consider the we are going to consider this one here, the mg sine, okay, beta. But now here we shall have sine beta, you see, even here sine beta, but then this way we shall equate to 0. Okay, so that is what we are going to be doing there. So let's go back. Now I'm going to have 150,000, that is the driving force, minus the resistance force, which is 22,000, and then minus the tension, minus the mg sine theta. So the m is 120,000, okay, g is 10, and then sine beta. Then I equate to 0, because remember, acceleration is what? 0 for constant speed. And then when we go to the coach, so the coach, we are having now the tension, then minus 13,000, okay, then minus 60,000, the mg sine theta, okay, 60,000, then times the 10, and then sine beta, then it's equal to 0. Automatically, we can add this such that the tension disappears. Okay. Now, when the tension disappears, we can simplify this one altogether. Okay. Okay. Now, what does this one give us? We have 150,000 minus 22,000 minus 13,000. That one gives us 115,000. So we have 115,000. Then after this one, of course, the tension disappears. Then sine of beta is common. So I can say, I can even take it this side. Okay. We are adding, then I can take it this side. Then I will say, this is 1, 2, 0, 0, 0, 0, and then the 10, also the 0. Then I'll add the 60,000, but these ones will be how many zeros? 5 of them, okay? Then sine of beta. You see that? So this is 1.2, like 1.2 million. And then you add 0.6 million, isn't that 1.8? So we have 115, then 000, which is equivalent to 1800, then 000, sine of beta. So meaning sine of beta is going to be equivalent to 115,000 divided by 1.8. So 1800, then 000. So beta is going to be the arc sine of these 3 zeros can go. Then we have 115 over 1800. So what do we get when we put in the calculator? Arc sine of 115 out of 1800. Okay, this one gives us 3.66, but to 1 decimal place for degrees, it will be 3.7. So beta is equal to 3.7 degrees, 1 decimal place, like that. Question 7. A particle x travels in a straight line. The velocity of x at t seconds after leaving a fixed point O is denoted by v meters per second. where v is equal to this expression here, okay? And then they are saying that the acceleration of x is 0 at t is equal to p, and t is equal to q, where p is less than q. Find the value of p and the value of q. Now, here we are given the expression for the velocity, so that means we are not supposed to use the other three equations of motion. V is equal to u plus at, s is equal to ut plus a half at squared, and v squared is equal to u squared plus 2as. We are not supposed to use them. But instead here for variable acceleration, we use differentiation and integration. Now, acceleration is the rate of change of velocity. That is the same as saying dv dt. Now, when I differentiate this one, remember you drop the power and then you reduce it by 1. So we shall have negative 0.3, then t squared. Then this one will be plus 1.8 times 2. That one will give us 3.6 of t. And then minus 6 here. When you differentiate a constant, it goes, okay? Now, they are saying that the acceleration is 0 when t is equal to p and also q. So that means I can equate this one to 0, okay? Then I can divide all through by negative 0.3, okay? I can factorize it here, then I will get, this is t squared, 36 divided by 3, you get 12. So that means this one will be a negative 12t, okay? And then 6 divided by 0.3, this one will give us a 20, okay? But I will put a plus because I took a negative here, because I always recommend that you use quadratics where the coefficient of, let's say, the t squared here is positive, okay? Now, when we factorize this one here, two numbers, when we multiply them, they give us 20, but when we add them, they give us negative 12. That means those two numbers are negative 2 and negative 10, okay? Is equal to 0. So meaning when I equate this one to 0, my t is going to be 2. And when I equate this one to 0, the t here is going to be 10. Now they say that the values of t are p and q, and p is less than q. So which one is less than the other? Q is therefore going to be 10 and p is going to be 2, okay? So that is what we have there. Then it is given that the velocity of x is 0 at t is equal to 14. Part B, find the velocities of x at t is equal to p and at t is equal to q. Hence, sketch the velocity time graph. Now, at t is equal to 0, okay, we get the expression for velocity. It was given as negative 0 point. So we shall have here negative 0.1 t cubed, then plus 1.8 t squared minus 6t plus 5.6. So we are supposed to find the velocities when t is equal to 2. So what is v when t is 2? That is negative 0.1 into 2 cubed, then plus 1.8 t, then squared minus 6 times t, then plus the 5.6. What do we get? So put everything in a calculator. Negative 0.1 into 2 cubed, because that will be 8, so that is 0.8, then plus 1.8 into 2 squared, then minus 6 into 2, then plus 5.6. So this one gives us a 0. Okay, then how about at t is equal to 10? The one of q, okay? So what will be v at 10? So negative 0.1 of 10, then cubed, plus 1.8 of 10 squared minus 6 times 10, then plus 5.6. What do we get? So I will just come here and then substitute. Wherever there is 2, I put 10. So that is a 10. Then I come to this one here. I also put 10. And then finally I come to this one here and I also put 10. Then it gives us 25.6. So this is 25.6 when V is equal to 10. Then I can also, since they have said that we are moving from 0 up to 15, so I can also say what is the value of V when T is equal to 15, okay? So V15 here is going to be what? So wherever there is 10 now, I'm going to put the 15. Where there is 10, put a 15. Then here, also the same 15. And then also here, 15. Then I get negative 16.9. Negative 16.9. The reason as to why I had to put this one here is to know whether the velocity is below the t-axis, okay, whether the velocity is negative, that is below the t-axis. So that means when you are asked, let's say, to find the distance, then you know that part which goes beyond the t-axis, and then you put modular signs on it because it is going to give a negative value, which is going to reduce your final answer. But when you realize, when you get to know that part of the graph which goes beyond the t-axis, then that means that you are going to put the modulus and then you get a positive value there because area cannot be a negative, okay? Now, our sketch is therefore going to be like this. Let me put this one like this. And when t is 0, okay, you realize that the whole of this one will go and then I remain with 5.6. So for 0, then I will have here 5.6. Here I can label this one as velocity, is in meters per second, okay? And then this side, I'm having my time, which is in seconds. Now, it is 0 at t is equal to 2, okay? And also, I can set 2 here, and then we have maybe the 10 is here. Then the other one is 14, okay, 14, and then we also have which other one? So we are going up to which one? We are going up to 15, okay? So there is 15 also. Let's say 15 is here. Now, this one is going to come like this. When t is equal to 0, I mean 10, what do we have? We have it as 25.6. So I can put this one here, 25.6. That is 25.6 there. So that means this one can come like this. And then it goes up here. Then it turns off from there. Then it will come and pass through here. Okay? Because they said that velocity is 0 when t is equal to what? 14. And then, but we have to go up to 15. So that's why I had to substitute this value of 15 to get where is v. So v is below the t-axis. Then I can put, maybe this is negative 16.9, which will correspond to the value of t15 here. So I continue this one here, like maybe up to there. There's a graph that continues. So that is going to be our sketch. Then part C, find the total distance traveled by x between t is equal to 0 to t is equal to 15. This is what I was talking about. If you check our sketch here, we have the part of this graph which is below the t-axis from here. So this one has to be treated differently. You're not going to integrate from 0 then to 15. Because there is a negative part here, it is going to cancel something from your whole value. So therefore, it is always very important to know the times when the velocity is 0. So I'm going to integrate from 0 to 14 because this whole thing is above the t-axis, okay? I don't need to say I'm integrating from 0 to 2, then 2, maybe to 10, then 10 to 14. That is wastage of time. It is all above the t-axis, so we just integrate all through, okay? All right, so let's go back. Our distance, total distance, you know, it is total distance traveled is total area under the graph, okay? It is going to be equal to the total area under the graph. And since here we are having a curve, then we just integrate. So we shall integrate from 0 to 14. Why are we even integrating this one? Because distance here is going to be, you know, displacement. I mean, velocity is rate of change of displacement. So it is ds dt, meaning s is going to be the integral of v dt. So that's why we are integrating the expression for the velocity, which is negative 0.1 t cubed, which they gave us, then plus 1.8 t squared minus 6t, then plus 5.6, okay, dt. Then plus we shall also integrate from 14 to 15, okay? That is the part which is below the t-axis, like we have seen before. Then plus 1.8 t squared minus 6t, then plus 5.6 dt. Then I can put this one in modular signs to make the answer, the final one, positive, okay? Now, when we integrate, you increase the power by 1, you divide by the new power. We shall have now negative 0.1 when you divide by 4. It's the same as saying negative 1 over 10, then times 1 over 4. So that is negative 1 over 40. So meaning I will have here negative 1 over 40 of t power 4, then plus 1.8, when we divide by 3, that one will give us 0.6, which is the same as 3 over 5, then t cubed, and then minus 6t squared over 2, that will give us 3t squared, and then 5.6 of t. Then put the limits, we have 14, and then 0, then plus the modulus of, remember when you integrate, you don't bring back the integral sign. It is a common mistake. You have seen that after me integrating here, I put my limits here, okay? The integral sign doesn't come back. So always remember not to bring it back when you integrate. And then inside here, we are going to write the same thing because we are integrating the same expression. So plus 3 over 5 t power 3 minus 3, then t squared, then plus 5.6 of t, and then you have 14 here. Then, sorry, this one has to be from 14 to 15. So 15 here and then 14. Then in the modular signs, now we can substitute 14, negative 1 over 40, then put 14 here, power 4, plus 3 over 5, 14 power 3 minus 3, then 14 squared plus 5.6 t, not t, it is 14, okay? Then after that I will subtract 0 because when I substitute 0 everywhere where there is t, it will be that 0. Then plus the modulus, put now 15, negative 1 over 40, then 15 power 4 plus 3 over 5, 15 power 3 minus 3, then 15 squared, then plus 5.6, then 15. Then after that, we shall subtract again this same thing that we put, 14. So 14, to avoid making mistakes, you put things in brackets, then plus 3 over 5, then 14 cubed minus 3, 14 squared plus 5.6, times 14. Okay, then I put my modulus. So when we put in the calculator, what do we get here? So we can have -1 over 40. Then this one, in fact, let me just write it as negative. Then we have 14 power 4. Then down here we have 40. Then plus, this is 0.6 into 14 power 3. Then minus 3 into 14 squared plus 5.6 times 14. So this one gives us 176.4. 176.4. Then we shall add inside here, wherever there is 15, I'm going to put, wherever there is a 14, I'm going to put a 15. So just come here, put 15. Again, let's go to this one here, put 15. Any other, this one here, put 5. Then also here, put the 5. So we have this one as 168.375. 168.375. Then minus, remember this one is the same as this one here. So I just put 176.4. Now you can easily see that this is smaller than this one. So the answer that comes out of here is a negative. 168, then minus 168.375 minus 176.4. Then we get negative 8.025. So 176.4 plus the modulus of negative 8.025. Then this one turns out to be a positive, right? 176.4, then plus 8.025. Now to make this one a positive, I would just say 176.4. And then I say minus the answer. Because it is already negative, then it will just cancel that negative and then it adds up. So this one will give us 184.425. 184.425 meters. I'm going to leave this one here as exact because the decimal places are really very, very small. So I don't need to round this off to 3 significant figures, and I write 184. So this has been it for this second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.